Next we'll see what is internal resistance of the cell. Internal resistance of the cell is represented using small letter R, internal resistance of the cell. So it is something related to resistance of the cell, isn't it? Internal resistance is some resistance inside the cell. We'll see what is that. We know that when current is drawn from the cell, so here I have shown the cell in that purple sketch. So when the current is drawn from the circuit, the current will be flowing from this is positive is anode and negative, you know, it is cathode. So the outside the circuit, the current will be flowing from anode, that is positive terminal, towards the cathode, that is the negative terminal. So it is not actually stopping there. The current will be flowing through the electrolyte also, isn't it? Then only the circuit will be completed. That is, inside the cell, the current will be flowing through the electrolyte or inside the electrolyte from cathode to anode. So actually when you are seeing the whole circuit, we could see that outside the cell the current is flowing from anode or positive terminal towards the cathode, that is the negative terminal, and inside the cell, inside also the current is flowing. So inside the cell the current is flowing from negative, that is cathode, to positive, that is anode. So while the current is flowing from the electrodes or between, current is flowing between the electrode, that is from the cathode to anode. So here the current is flowing from inside the cell, the current is flowing from cathode, that is negative, towards the positive. Inside the cell you have the electrolyte, isn't it? So this electrolyte will offer a resistance for the flow of this current. Okay, electrolyte will offer, electrolyte is a conductor, and that conductor or electrolyte will offer a resistance for the flow of current inside the cell, and that resistance is known as internal resistance, which is represented using small letter R. So you can define internal resistance as the resistance offered by the electrolyte inside the cell to the flow of current. Okay, so how will you define internal resistance? We can define internal resistance as internal resistance of a cell is the resistance offered by whom? By the electrolyte in the cell or inside the cell to the flow of current, to the flow of current. So that is known as internal resistance. It is represented using small letter R. So it is easy to understand. Internal means inside the cell, the resistance which is inside the cell due to the electrolyte, that is known as internal resistance. Internal resistance of a cell is the resistance offered by electrolyte. Electrolyte is providing or giving a resistance for the flow of current. So that is internal resistance of the cell. Now when you are representing the cell including the internal resistance, mainly we represent the cell without any internal resistance. Since internal resistance is very small, we usually neglect that. But suppose you are considering the internal resistance, so you have to draw it in this way. So this is our cell, okay, and along with that cell you have to draw a resistor which is in series, that is in line with the cell. So that represents the internal resistance. So you can write here, this is the EMF of the cell, that is the voltage given by the cell, and side by side you have a resistance, that is internal resistance represented using R. Okay, and all together, that is this particular section, this is positive of the cell and this is negative of the cell. So that can be considered as the whole cell with internal resistance. Okay, so internal resistance, if you are showing internal resistance, always show the internal resistance in series with or in line with the cell which you have drawn. So this is how we represent internal resistance. Now if suppose a current I is flowing through the electrolyte, that is, if let I be the current flowing through the electrolyte, then voltage across the internal resistance, you know from Ohm's law we have V is equal to IR, isn't it, where R is the resistance, V is the potential difference or voltage, and I is the current. So let us suppose that I is the current flowing through the electrolyte. I is the current flow through electrolyte. And let us suppose that small r is the internal resistance, that is the resistance which is offered by the electrolyte. Then you can say that voltage across, or voltage drop, we can say it as voltage drop across cell, that is whatever voltage is dropped across the cell or lost across the cell due to the internal resistance, that can be represented using small letter V, is equal to current flowing multiplied with the resistance there, that is V, small v is equal to I multiplied with internal resistance. So this much voltage will be dropped in the cell due to the resistance. That means we will not get this much voltage outside. Okay, so this will be lost due to internal resistance of the cell. It will be very, very small in value. Getting? So suppose we have a cell which is having voltage, let us suppose that 1.5 volt. So this 1.5 volt, which is the EMF of the cell, it won't be completely obtained in the circuit. We won't get this complete 1.5 voltage in the external circuit. Maybe we will get 1.45. So that 0.05 volt will be lost due to whom? Due to the internal resistance. Getting? So due to internal resistance, some voltage will be lost, and that is actually known as the voltage drop across the cell, across the cell, not cross, across the cell. Okay, so that is about the internal resistance. So internal resistance actually is there, but in most of the cases we don't consider that internal resistance because it is very, very small compared to the EMF of the cell, voltage of the cell. So we don't consider it, but wherever we need to consider the internal resistance, we have to keep in mind all these points. That is, we have to draw a resistance series with the cell, and also we have to consider the voltage drop V is equal to I R, which is lost actually, which we won't get in the external circuit. So that is about the internal resistance of the cell. We'll see the factors affecting internal resistance of a cell. So there are 4 factors that affects the internal resistance of the cell. The first one is surface area of the electrode. That is, we have cathode and anode, and that cathode and anode will be having a particular area, or that are actually made of metal. So that metal will be having a particular surface area. So the surface area of the electrode will determine the internal resistance, or will affect the internal resistance. That is, if surface area is more, internal resistance will be less. So that is the relation. More the surface area, the less will be the internal resistance. Now the second factor that affects the internal resistance is the distance between the electrode. Distance between the electrode means distance between the positive anode and negative cathode. So there is a distance between them. If D is the distance between the electrodes, then we can see that if distance is more, then the internal resistance will also be more. So that is the relation. More the distance between the electrode, then more will be the internal resistance. Now the third factor that affects the internal resistance of the cell is the concentration of the electrolyte, nature and concentration of the electrolyte. That is, we can use dilute electrolyte as well as concentrated electrolyte. So if concentration is more, then the internal resistance will be more. More the concentration, internal resistance will be more. So that is the relation. If it is not that much concentrated, if you are using less concentrated electrolyte, then internal resistance can be reduced. Now the last factor that affects the internal resistance is the temperature of the electrolyte. So the temperature of the electrolyte, if it is high, then we can see that the resistance of internal resistance of the cell will be low. So more the temperature of the electrolyte, the internal resistance of the cell can be seen to be less. So to conclude, we'll just conclude that 4 factors are there. First one is the area. When area is more, internal resistance will be less. Second factor is the distance between the electrodes. More the distance between the electrode, more will be the internal resistance. Third factor is the concentration. So more the concentration of the electrolyte, then greater will be the internal resistance. And fourth factor is the temperature. More the temperature, internal resistance will be less. More the temperature, less will be the internal resistance. So these are the factors affecting internal resistance.